Right. All right, so out of this we've gone over already. We went over the tip direction. We've gone over cutter comp. We went over G71 and the G72. Okay, so we had left off on this, correct? On the lathe? We did this part in class? All right, so I'm just gonna explain. We did that. I'm just gonna explain this to you guys real quick. On your G71s, this is a type 1, right? Some of you guys were getting an alarm when y'all were doing this, and it's because your X value further down the program was less than the previous X value. Does that make sense? So if I do a G71, the most common one is a type 1 when the part ends up going up on X, right? It keeps on increasing. So that's a G71 type 1, where your X keeps on going up in a positive direction. You're not going to have any problems with that as long as it keeps on going up, right? So you guys see how right here, I have an X value here. Then my X dips down. Then my X comes back up. You guys see that? If we do a regular G71 type 1, all day long, we're going to get an alarm for that. Does that make sense? So for that, we need a G71 type 2, right? So the only difference between a type 1 and a type 2, I need to put a Z value here, right next to the X. That's how I make it from a type 1 to a type 2. Does that make sense? Trying to see where there's an example. See, right here it's explaining type 1 details, type 2 details, right? Right here. You guys see this? Are we tracking?
Got it. Just got to the page.
So you guys see how on that end line, there's a Z value there also? That's the only difference between a G71 type 1 and a G71 type 2. Trust me, guys, I've worked with guys that were programmers for years. And anytime your X slightly goes up or down, right? You get a code that says like non-monogamous, non-monogamy, something like that. But that's the code you get. And it's because you're still on the G, huh? Yeah, that one. But I call it non-monogamy, bro. It just sounds better. So, you get that alarm whenever you have a G71 and you're trying to either go down, you were up on X and then you're trying to go down or whatever, right? So a lot of programmers, when they get this problem, what they end up doing is they just take it out of CAN cycle. So they take that G71 out and they do it line by line. It'll run great, line by line. But look at this part right here, for example. Look how much code there is. How many lines is that? 18 lines to make that part. How many lines do you think it'll take you if you didn't use can cycle?
Too many.
Never be done.
A lot more. But so a lot of programmers just put the program back in the software, and they just click no can cycles, or they unclick the can cycles button, right? And that's it. And they give you back the program. Now you got a long ass program. So if you got a problem, guess what? Now it's held on you to try to find where that problem's at. But all you had to do was add a Z value right there. Does that make sense? So here's another example of a G71 and a G72 type 2 roughing. So if you guys want to do this, it's a good challenge for you. Page 93. I'm not going to make it mandatory because you guys already have a lot on your plate, right? But if you want to make more than the simple parts that we've been making, this is a good example to know. Does that make sense? Now, I want to get to the drilling before we get to the ID, because it's just going to make a lot more sense, because we have to drill first in order to bore an ID, right? Does anybody need a break? Gotta go to the restroom or anything? No? What happened?
No, say no.
All right. So this is a G81. Just like on the mill. We had a G81, right? So this G81 is very similar to the other program. We have our G28, which is gonna send our machine home, right? We have our tool. Then we have a G97. Notice, guys, now with the drill, we just have a G97, right? We don't need a G96 because we're not even moving on the x-axis once we start cutting. We're remaining on X0. 9 times out of 10, if you're drilling on a lathe, you're gonna drill on X0. Does that make sense? Most of the time, if you drill a hole on the lathe and you don't have a ID boring can cycle afterwards, it's because you're doing a through hole. Like water's gonna go through it, some type of liquid. Usually not hydraulic, because for hydraulic to pass, it's usually gonna be precision. So you're gonna drill, and you're gonna bore the ID. But if you're just drilling for water to pass through or anything, you're just gonna drill on X0. Does that make sense?
Yeah.
So let's look at our program. G28 takes it home. We get our tool number 1, offset number 1. G97, S1450. Do not put 1450 on that lathe machine out there in our shop, right? But we have to put an M03 on there. So then we got a G54. We always got to tell it where our Z0 is at, and our X is reference to the 0, our X0, correct? Then look at our program, X0, Z1. So it's going 1 inch in front of the part. M08 turns on my coolant. Then I have a G81, Z minus 0.625 R1 feed rate of 5 thousandths. So on this line, we were at Z1, X0, right? We fed in at a feed rate of 0.005. Well, we went to a rapid plane first, which is right here. This is a rapid plane. of 100 thousandths. Then we fed in, this is part 0. So from here, we still went 625 thousandths in. Does that make sense? From our face, from the Z0, we went in 625 thousandths. Then we're gonna rapid back up to our R plane, which is 0.1, correct? Then we cancel our can cycle. We rapid back forward 1 inch, turn off our coolant, go home. Too easy? The other one is easy too, but you just have multiple holes and multiple locations. This one just seems easy because it's X0. That's it. You are home. Make sure you guys are writing down notes. Make sure you guys are, there's only 9 lines of the program. You could write this program not even in a minute. Make sure you're doing this and you're practicing it. Why? Because you're going to be tested on this, guys. One of these CAD cycles is going to be on your test. Are we tracking? All right. Next is a G82. That looks familiar, doesn't it? Same thing that we did, right? So, same type of layout, guys. G28 is at home. 4202. 22 offset 2. G97, S1450. G54, G00, X0, Z 1 inch in front of the part, right? This R is what's going to wrap it this plane. So it's okay if you're 1 inch in front of the part. So then we have a G82. So we're going to drill in. This is our 0. We're going to drill past 625. So go in there, right? Now we're going to stay there for 0.5 seconds. Y'all see that? So it's going to clean up the bottom of that hole all nice and clean. Then we're going to wrap it back forward 100 thousandths. And that drilling inside, it's going to be done at a feed rate of 0.005. So when we come back out, we're going to cancel our can cycle. We're going to wrap it 1 inch in front of the part, turn off our coolant, go home. Too easy? All right. So we also got a G83 when we're drilling on the lathe. Same thing, guys. We have an I, J, and K value. So if we don't use that, a minimum, we need the Q, right? So here is the program for it. Same thing as the intro stays the same. The conclusion stays the same. So it's pretty much the same thing as this program, right? But instead of that P, we have a Q value. Does that make sense? So I did my intro, went home, got my tool number, started up my spindle, right? Got a G54, G00, X0, Z 1 inch, which that's what's right here, right? G54, G00, X0, Z 1 inch. Turns on the coolant. G83, X minus 1.5. So my depth is going to be 1.5 inches. So right here, I give it a Q.2. So it's going to be going in 200 thousandths every time. 100 thousandths, right? But I have my retract of 100 thousandths. So it's going to go in 200 thousandths, retract 100 thousandths. Go in 200 thousandths, retract 100 thousandths. Go in another 200 thousandths, retract another 100 thousandths again. Does that make sense? If you guys look at these Q's up here, it better explains it by view. So 200 comes back, 400 comes back, 600 comes back, 800 comes back. At a feed rate of 0.005. And after that, you just send it home. Cancel your can cycle, G00, G1, M09, G28, M30. Too easy? All right, so there is also tapping on the lathe. It's not that common because there's so much torque and force on the chuck. A lot of times you end up breaking the tap when you tap on the lathe. But same concept, same code right here, guys. Make sense? All right, so this will be your lathe homework. Page 89. And we pretty much gone through this, correct? Remember when we were doing this exercise up here?
Yeah, that we did like a week or two ago or something like that.
Yeah, so we did. No, we did it. Where were we at? Jeez.
I did put a date on it, but it's when we covered circular paths.
Yeah, I know it's close. Right here. Page 41. Similar to page 41, right? Is what we have our homework right now. On page, what did we say? 89, guys?
89, yeah.
Yeah. 89.
Yeah, it's 89.
So this
Look for
89 one. This one, like I said, guys, I'm trying to teach you like real life stuff, right? So obviously in a real shop, we would have faced this part. It would have been faced, correct? If I had an inserted drill, like we have out there in the machine shop, it's a drill with the inserts on the sides. Well, this hole right here is 3.5 deep, right? So hopefully my drill would have been a 1-inch drill, correct? I would have used a G83 after I faced, so I would face with what? A G72, correct? So face that material off. Then I would have a G83 from the X0, boom, drill out that hole, correct? Drill it out, put it to 3.495. So I leave 5 thousandths on the wall, right? Then I would come in with my boring bar and do this work with the ID. Does that make sense? Now, notice though, that on this G71, it's the same concept as I told you earlier. This is a type 1. When I'm identifying this, I could only go lower on my X. I can't go higher. Does that make sense? Because I would make it a type 2. Right now it's a type 1. So let's explain this part real quick so I could get you guys going a little bit on it. And I don't want to hold you up too much because normally it's 2 hours of lecture and the rest of the time is in the lab. And I'm tired of talking. I feel like I've been talking for a while. Yeah, so I'm trying to finish this off and let this be the end, right? So, yeah. No. This is the stock material, right? So that's your part. We're using a drill to hollow this out first. Then we're coming in with the boring bar and we're going to take off all this material. Yeah, but you had, okay, I probably heard you wrong or whatever, but that's what it is. So it's kind of like working the opposite, guys, of an OD part, right? An OD part, you had to establish your start here, and then you had to work your way down from the part, right? Well, on the ID, we have to establish our start here, and then we work our way here, though, and then we work our way down. Does that make sense? So this start point has to be below whatever we drilled, right? So that N5 G54 G00X, X has to be at 1 inch or at least a little bit under 1 inch. Does that make sense? Because we got 1 inch right here, right? Then we got a G96 S420 G71 P8, so that P matches that 8. That Q18, that Q matches this 18, correct? Q negative. Understand, guys, that if we're doing the ID, leave more material to clean up on your finish pass, we need to have a U negative because that's incremental. If I put U positive 0.005, I'm going to make that part bigger on the ID. And then W, it still leaves the extra material for the finish pass on the walls, right? So then we got our N, our D, 80 thousandths, fee rate of 10 thousandths. So then we have our N8, G41, which is what? Cutter comp left, correct? Remember, OD is cutter comp right. I mean, the G42 is cutter comp right. G41 is cutter comp left, correct?
So on this one, you don't have a, like, it wouldn't be N8 G41. It's just G41 when you're punching in the actual program.
Right here? Yeah,
Right.
it needs to have N8 because that P. These don't have to need, these don't need N1 and 2 and 3 and 4 and 5. These don't need that.
Okay.
Right?
So that's what's kind of confusing because they're labeling all the number lines.
Yeah.
They're not telling you what needs to be typed in.
This P needs to match this N8.
So
right?
you have to type in that N8.
Yeah, none of these have to be here.
Okay.
N1 and 2 and 3 and 4 and 5 and 6 and 7, that doesn't need to be there. What needs to be there definitely is the N8 because it matches plays with the P, remember?
Right.
And then the Q18, so you have to have the N18. Like I said, there's a feature on the machine that if your lines aren't numbered, you could just pick F1. I can't remember if it's F1 or not, but you could just click it and just put number the lines, and it's gonna number all of them, all the way down. But you don't need to have them. The only ones you do need to have are the ones that match with your P and your Q.
You think it'd be smart enough to pick that up, but I guess not.
No, because you need to establish the start, right, and the end of your geometry.
Mm-hmm.
You need to establish that. So we have a G41, G00, N8. Look what it says. Start position of part path geometry. So that one indicates that it's going to be right here. Does that make sense? That's the start of my geometry. So if this has a radius of 0.05, right? And this is X 2.630. So this will be at least X 2.730. Does that make sense? Actually, it will be X 2.830 because we want to go 100 thousandths above. So X 2.830. Everybody tracking that?
Yeah, because you're taking 100 thousandths for each side.
Yeah, plus another 100 thousandths, right? Just because
It's X, so you
I
double it.
want it to be above before it starts that radius to come down here. Does that make sense? Before this little radius, I want to be above it a little bit because I'm cutting down here now, right? So then I have a G01, Z0. So now my tool comes in front of the part, right on my Z0. Now this X value, so it's going to come right here at the start of this radius, right? So now that one is X 2.70 because it's X 2.630 plus 50 thousandths plus 50 thousandths. So that start of that radius is X 2.730. Are we tracking? That's for number 10.
We're talking just about the inside radius, though, right?
We're identifying the geometry right now. Yes.
Right, on the inside.
So obviously the next line is G02. So from here to here, it is 3 o'clock to 6 o'clock, right? And it's even telling you X 2.63. So right there, X 2.63. It's giving you the answer right there, right? Z minus what? Well, you got the radius there. So what would that Z be? Exactly. Z minus 0.05. And there you go. I started you off with your homework. Negative.
Mm-hmm.
All right. So how'd you guys like this?
Yeah, once you start adding in math.
Machining is math. What are you talking about? But yeah, But all right, guys. I don't want to keep you any longer. I know y'all probably got stuff to do with your personal lives, so get to this on your own time. But like I said earlier, make sure you study. All right? Because if you don't study, you're gonna fall behind big time. We're very busy coming up on Monday. We got to do retests. We got to take tests. We still got to learn more information on the lathe and the mill. We need to execute it on the machines. And you guys still need to review and practice before Tuesday and Wednesday of the following week. Does that make sense?
Yes,
Yeah.
sir.
All right, y'all know what y'all got to do. Does anybody have any questions at all?
Yeah, I have a question.
No.
Okay, for the late, the homework is on page 89 and 41, right?
Page 41 is your reference to 89.
Yeah,
Okay.
41 you should have done already.
Yeah, that's my question only.
Okay. Yeah, like I said, guys, I'm gonna try to save this and send it an email. Hopefully it lets me. If not, get with Corey and see if he can email you this lecture if I can't upload it or anything.
Well, does it, because this might be kind of large, does it like the Lone Star have a share cloud or something like that?
Yeah, it does, but I don't know.
Because you might just
Exactly
be
how to
able to
do that.
send a link to it, but
Yeah, I'm gonna try to upload it like on the cloud. And I know like when I took SolidWorks, this guy got the instructor had Google Cloud and you had to log on to Google Cloud. Then you were able to access it through there. But I'll see what I could do.
yeah, I think the Lone Star has like OneDrive or something like that.
Yeah.
All right,
All right. Well, you guys take care.
later. Have a good one.
Yes.